You are looking at a piece of history. The first photo taken by a camera aboard a reconnaissance satellite. It shows Mishmita Airfield in what was then the Soviet Arctic. The photo was taken on August 18, 1960, by a camera mounted on a satellite called Corona. By today's imagery standards, the photo looks fuzzy and distant. Yet it was of great value because it was the first, one of many firsts for the Corona satellite reconnaissance program.
No one wants another Pearl Harbor. This means that we must have knowledge of military forces and preparations around the world, especially those capable of massive surprise attack. Secrecy in the Soviet Union makes this essential. In most of the world, no large-scale attack could be prepared in secret. But in the Soviet Union, there is a fetish of secrecy and concealment. This is a major cause of international tension and uneasiness today.
Traditional reconnaissance options were limited. So in 1954, President Eisenhower approved the U-2 program under joint CIA Air Force management. At about the same time, the Air Force began a new effort, referred to as Weapon System 117L, which included a number of Earth-orbiting satellite reconnaissance projects. With the concurrence of senior congressional leadership, Eisenhower also approved a new covert satellite reconnaissance program. Spun out of 117L, it was to be jointly managed by the same CIA Air Force team which created the U-2. Publicly christened Discoverer, the program included a biomedical research mission. But the primary mission was intelligence, and the program name was Corona. Corona began under utmost secrecy. The Air Force, specifically its Ballistic Missile Division, would be responsible for the development, launch, and operation of the spaceborne vehicle as well as recovery of the payload. The Central Intelligence Agency would be responsible for developing and procuring reconnaissance equipment and selecting the targets for imaging. The Corona program was envisioned to be a series of satellites that would carry cameras to photograph denied areas. Launched into polar orbits by Thor boosters, the spacecraft would fly at approximate altitudes of 100 nautical miles and take pictures of selected target areas. The exposed film, returned to Earth in capsules ejected from the satellite, would be snatched in mid-air over the Pacific Ocean and airlifted to processing facilities. Dogged perseverance paid off, with the success of the 13th launch, publicly announced as Discoverer 13 on August 12, 1960. This flight, designed to test the recovery vehicle, had no camera aboard. The vehicle was successfully launched, orbited, and deorbited. One week after the Discoverer 13 water recovery, Discoverer 14 achieved full success. The vehicle carried a 20-pound load of film. The camera worked perfectly, and a full load of film was exposed and transferred to the recovery capsule. Ejected on the satellite's 17th pass, the film capsule was successfully snatched in mid-air by an Air Force C-119 aircraft. Just 110 days after the U-2 incident, Corona had made a quantum leap in intelligence gathering by operating from the new high ground of space. 3,000 feet of film were acquired on Discoverer 14's historic flight. More than 1,650,000 square miles of Soviet territory had been photographed for interpretation, providing more coverage than all of the U-2 missions over the Soviet Union throughout previous years. The 145th and final Corona launch took place on May 25, 1972. Having achieved its purpose, Corona's existence is now unclassified, and its artifacts have been made available to the Smithsonian Institution so that others might gain a sense of how far-reaching the program's unsung heroes were in their pioneering efforts. The camera and 2 buckets from Corona's last flight will be part of a permanent exhibit at the Smithsonian's National Air and Space Museum. The team members who made up the Corona program can take just pride for their achievements in intelligence gathering, as well as their scientific and technical contributions. They have compiled an enviable number of lasting firsts. The first use of a satellite to gather photo intelligence, the first mid-air recovery or catch of a re-entry vehicle, the first mapping of the Earth from space, the first gathering of stereo-optical data from space, the first use of multiple re-entry vehicles, the first space reconnaissance program to fly 100 missions, an unmanned spaceflight endeavor that provided leading-edge technology to future manned spaceflight,